Okay. Oh, welcome back to part 2 of this class. I'm going to start with just a quick review, very quick, of 1 or 2 of the other slides we ended with last time, because I'm going to show a video on the subject in just a minute. This is the domestic wastewater treatment plant process flow diagram. And you might remember from last week, I mentioned that there are different parts to this treatment process: primary, secondary, and tertiary treatment. Domestic wastewater is the water that we send down our toilets and down our showers and sinks. It goes to a wastewater treatment plant. So you can the film with the video we're going to see will talk about the different stages: the primary, the secondary, and the tertiary. Each level takes the cleanup process to a higher degree. That's the slide. Okay. And if you get into the real high level of treatment, you've got some other steps, but we don't need to look at the slide again. All right, well, this is about a 7-minute video, and it is on what is probably the world's largest wastewater treatment plant, located in Chicago. It is narrated by one of the supervisors at the plant, and he will take you through the processes, and you can see actually what it looks like and get a sense for the size of the plant. Tallahassee is a similar wastewater treatment plant, but Tallahassee's is dwarfed in size by what they're doing in Chicago. This is the checkers getting the grants on. Okay. My name is Rich. Just not enough. This time was originally called Mercy.
We're not seeing anything.
Halt the video.
Can you see it now?
Yes.
Restored.
We can't hear it.
They can't hear it. All right. Well.
You have to check this.
I don't know where the volume is. I mean, I want to show you.
We can't hear it.
I can't hear it.
We're going to just,
Can you just describe it?
we're just skipping. Here. No, I don't hear
Stop it. Okay, good.
All right. Can you hear me now?
Yes,
Okay, well, unfortunately, we're gonna have to pass over that. If anybody's really interested in that, I'm sure we can get you the link. This is a nice description of a wastewater treatment plant. All right. These are various pictures of wastewater treatment plants for domestic wastewater that I grabbed off the internet. They all have one thing in common. They all look kind of the same, I think. If you've been to one, you've been to all. It's kind of the way I view it. And I have been to a lot of them. If you're a wastewater engineer or somebody that actually works at one of these plants, I'm sure that the differences and nuances are a little bit more obvious. And actually, they do not smell as much as you think they might. If you're in an area where they're using chlorine, yeah, that's probably the most noticeable smell at a plant like this, but generally it's not very smelly. These are 3 bottles of water, and they show the different degrees of treatment. The one on the left is the water that comes into the plant. It's called raw sewage. That's sewage, okay? As it goes through the plant process of being treated and cleaned, nobody there calls it sewage anymore. They call it effluent. The media loves the word sewage. So no matter how much it's been cleaned up, they love to use the word sewage. The water in the middle has gone through the secondary treatment process, probably, and it's quite clean, but it's still a bit cloudy because it's still got some suspended solids in it. The water on the right, which is named reclaimed water, that's gone through extra filtration, and most of the suspended solids has been taken out. It's got less than 5 parts per million suspended solids on the right. The reclaimed water is high quality, good enough to spray on green spaces like golf courses, good enough to come in contact. If it should accidentally come in contact with people, it will not harm people. You just don't want to drink it. And it's clearly marked non-potable water. Can a domestic wastewater treatment plant accept industrial wastewater? The answer is yes, but it depends. An industrial facility may have to make an application to the domestic utility to send their water to them. If it's a large amount of water or it's kind of nasty water, they will probably have to treat it themselves and possibly send it to some disposal point on their own. This is play golf. Probably seen this. Golf courses get irrigated quite often, and in areas where they have reclaimed water treatment, that water can be sold to golf course owners and operators, and the city can recoup some of the money they've used for treatment. So it's actually a real win-win situation for the city and the users of reclaimed water. In St. Petersburg, actually, many of the residents can use reclaimed water to irrigate their own lawns. They have a separate piping system for that. So there's not going to be any mix-up between that water and the drinking water. And don't know if I showed this last week. There's a picture of a reclaimed water system in Panama City. There's a sign telling what it is. At the bottom, it says, do not drink. I don't know if I showed this last week. Can wastewater be hazardous? Well, it can if you're not careful, but it almost never will be. There's always treatment, and it should definitely take it out of the realm of hazardous waste very easily. Your own sewage that goes to a wastewater plant is not even considered hazardous. It's unhealthy. What will make wastewater hazardous? It could be a number of things, and it's hard to generalize about. If it had lead or arsenic that was in very high levels, for instance, that could make it hazardous. If it had a pH that was too low or too high, that could make it hazardous. If it is ignitable, corrosive, reactive, or toxic, that could make it hazardous. But other than those general guidelines, it falls to the people that actually study that for a living to make that determination. But most, let me say this, the vast majority of wastewater is not hazardous. But can hazardous wastewater be disposed of? Not in our state. It would first have to be treated to be non-hazardous. They'd have to do something to remove whatever hazardous constituent it had. If it had lead, they'd have to remove the lead. If it had a low pH, they would have to raise the pH and so on. Then it could be disposed of. All right, we're going to leave wastewater treatment finally. We're going to move on to wastewater disposal. After all that treatment, there's still a very important step left, and that is doing something with all that water. So reminder, this is domestic wastewater from these sources that we send to our wastewater treatment plants. This is a domestic wastewater treatment plant, typical of what we have in Tallahassee. Tallahassee is permitted to accept and treat 25.5 million gallons per day of domestic wastewater. Now, it normally doesn't have to treat that much, but there are some days where it does have to treat that much. And once it gets treated, it all has to go somewhere. It doesn't just stay at the plant. Every domestic wastewater plant and every industrial wastewater plant, if they're permitted to treat water, they're also permitted to dispose of it somewhere. And I like to say when we get into discussions about wastewater treatment and wastewater disposal, I always remind them, you know, no matter how much you treat it, it's got to go somewhere. All right, where can it go? Where can it go after we treat the wastewater? There's a few general options. The tried and true and old-fashioned option was generally always surface water. Treated water or not so treated water went into surface water, which is how we got our surface water polluted. It wasn't really treated to a very high degree. But now there are many more restrictions on treating water that is disposed of into surface water. Groundwater, that can accept wastewater as well. It might be allowed to infiltrate into shallow aquifer. It may drain into a well or be injected into a well using deeper aquifers. We'll touch on that in a bit. And then for more advanced wastewater plants, they can treat it to a high degree and that water can be reused, like irrigation at golf courses or parks. And there's a lot of talk these days about something called potable reuse of water. of wastewater. In other words, some of the very, very highly treated wastewater may someday be allowed to be a small part of the potable drinking water supply in the state and in other states too. Florida's not there yet. We're not doing it, but there are pilot projects in our state testing that. This is the big wastewater plant in Chicago that you missed on the video. Excuse me. This plant, the Stickney, not Stinky, Stickney water treatment plant or water reclamation plant. It treats over 2 billion gallons of water per day if it needs to. On an average, it treats about 700 million, which is still a lot. I think it serves basically all of Chicago. Maybe other plants, but I think that water from other plants winds up going to this plant where it gets further treated. During times of extensive rainfall, this plant, as well as all other domestic wastewater treatment plants, will have a lot of more water coming into the plant for treatment. It's stormwater. It gets into the plant. Normally because of breaks, holes, imperfections in the transmission lines that take the sewage to the plant. Is during high periods of high rainfall, some groundwater gets into those transmission lines, or maybe there are storm sewers that feed the plant. This stormwater runoff. I mentioned before that, oh, let me back up here. Sorry. I'm done with this slide. So in the upper right-hand corner is a canal or a river. It has got the romantic name of the Chicago Sanitary and Shipping Canal. It connects Lake Michigan with the Illinois River, and the Illinois River flows into the Mississippi River. Years ago, the city would send its wastewater from the plant to the canal, and that would go into Lake Michigan, which is, let's see, north is to the left. So that would be going in a direction away from us toward Lake Michigan. Problem is, Lake Michigan serves as the drinking water supply for Chicago. So over the years, they upgraded the treatment and changed the direction of flow. They engineered it so that the flow now goes in the other direction into the Illinois River and eventually the Mississippi River. So that's where Chicago gets rid of most of its wastewater. I mentioned before briefly that it's possible to have an injection well where you can dispose of wastewater. This is a pretty big thing in Florida. Not as much in a lot of other states, but some other states do have a lot of injection wells. Having an injection well, this is the top of one, the upper part of it, can dispose of quite a bit of wastewater if you have the right kind of geology in the deep in the subsurface. You have to have a geologic formation that is permeable, just like you need a geologic formation that is permeable to be an aquifer. An aquifer like that, if it's much deeper and very salty, can accept a lot of wastewater that is pumped down there. This particular well in Manatee County can safely dispose of 15 million gallons of wastewater per day into a saline or salty aquifer. We'll come back to this slide in a bit. What it's disposing of, though, is domestic wastewater. And it gets secondary treatment. This is one of the older wells, circa 1988. The new wells have to use a more advanced treatment. They use that tertiary treatment. same as reclaimed water quality, which is sprayed on golf courses. Sorry, you can't see this all that well, but this is a downhole view of one of these deep injection wells in Florida. And it's not just, it goes into a pipe, but it's not just one pipe. It's a series of pipes that are set deep enough to protect the different aquifers down there. And the deepest pipe goes down to a depth of 1,600 and 1,850 feet. This is a different well than I was showing you a second ago, but it serves the same function. And over on the left-hand side, we see the geology, and all these different patterns represent different types of rock. This aquifer it's going into is called a dolomite, which is very similar to our limestone. In this particular, dolomite is very, very permeable and will accept a lot of water. The rocks above them have much lower permeability, and many of them do not serve as aquifers at all. The term aquifer, I wanted to discuss. I know I discussed it last week. Geologists that study groundwater, they use the term aquifer, even if it's a very deep aquifer and has only salty water in it that nobody could drink. It's still used as, the term is still an aquifer. So when I say they pump it into an aquifer, they're pumping it into an aquifer that the groundwater has a water quality the same as seawater. It's that salty. And all these layers up here above it serve to protect the groundwater that actually is usable. This is when they drill one of these wells, in Florida at least, they run a camera down the hole before they put the pipe in there. And they run a video camera up and down the well, and you're actually seeing a picture of the rock at this depth, 2,762.8 feet below the land surface. That's the depth of the well, and you're seeing what looks round here for the most part. That's the well that they drilled through the rock. This gray yellowish area is the rock around it, and these voids at the top of the screen and one at about 2 o'clock to the right. These are fractures in the rock. They're naturally occurring. They're not made by man, and they help the aquifer accept a lot of water without causing a big pressure buildup at the surface. There's very minimal pressure buildup at the surface of the well. Very fascinating in geology. So this is the well I showed before. So just to show you what you're looking at here, this here is the well right here. At the top, and at the bottom, you've got some valves that keep the well open to accept the water. If they need to turn it off, they turn the valve off. They can read the pressure on a gauge at the top of the well. This line on the left is the transmission line from the treatment plant. It takes water up to 15 million gallons per day into the well. And then it goes down over 1,000 feet deep. That pipe is painted green. Pipe is painted purple. For some reason, don't know why. Reclaimed water in Florida, if it's sent through a transmission line, the pipe is supposed to be purple. So if you see purple pipe out there, it may be a reclaimed water transmission line. As a reminder, I mentioned last week, if you are not connected to city water or city sewer, I should say, then you probably have a septic tank, and the wastewater from your house goes out a septic line and to what's called a septic tank, which is a concrete structure. It provides minimal treatment of that water, some biologic treatment. It separates floatable matter like oils and greases and solids from the wastewater. And then the wastewater goes out to a series of drainage pipes, what's called the drain field. And then that water percolates downward until it hits the water table and joins the water of the upper aquifer. So as you can imagine, that water does not get a very, very high degree of treatment. But that's why they have rules on how many of these systems are allowed in a given area. They can't be very close together, and they can't be very close to anybody's well. And one thing I didn't say, because I'm probably going to use the word a lot, whether water is coming from the house going to a septic tank, or whether it's going down one of these deep wells, what the word we use for that is they are discharging the water. They're discharging the water from the treatment plant to wherever they're sending it to, a well or a surface water body, or in this case, eventually to a drain field and the upper aquifer. Discharge. So if I keep using that word, that's what it means. Industries that have large volumes of wastewater, or if they have wastewater that has characteristics that prevent them from sending it to a domestic wastewater plant, they need to treat and discharge their own wastewater. A plant, I don't know what kind of plant this is, but it's awfully big. And I would imagine they have to have their own treatment process and their own disposal or discharge process. Treatment criteria for an industrial wastewater plant is not real standardized like it tends to be for domestic wastewater. So we're not going to get into that. It's way beyond what I would ever want to cover. But there are rules for that. To what degree they have to treat the water, it depends on where they're discharging it to and what the rules are for protecting the water body that they are discharging it to. If this is discharging it to surface water, those are usually the most stringent criteria that they have to meet before they can discharge it to surface water. I've got a number of slides here on stormwater. I'm actually going to skip most of them, but I just have one or two I will go through quickly. Stormwater is not, strictly speaking, a wastewater, I guess, but it's still regulated like a wastewater in a lot of ways. So stormwater is water that runs over roads and through parking lots, through developed areas. Maybe it comes from agricultural fields. It's surface water that runs over these areas. And what we're seeing is one of the several methods of keeping stormwater from introducing contaminants into water bodies, whether they be groundwater bodies like aquifers or surface water bodies. This is merely a trench, a linear trench, and it's filled with gravel. And you're seeing a side view or a cross section of what this trench looked like if you could see into it. It's got gravel, pea gravel, clean gravel, stone. It's basically all gravel. It's commonly used by the Florida Department of Transportation and other state DOTs, Departments of Transportation around the country, to deal with stormwater along the sides of the roads. As you might gather from looking at this picture on the left, there's really no treatment going on other than what contaminants might be contained, kept back, held back by the gravel and maybe some of the material within the gravel. So the water flowing out of this trench, it's not meeting the level of treatment that we saw on the domestic wastewater side of things. But it provides some retention of the water before it leaves that area. Now, stormwater quality is highly variable. I've seen water sample results from stormwater, and some of it looks like you can drink it, and some of it looks awfully nasty. It's highly variable depending on whether you've had a big rain or depending on what type of surface it's flowing over. I mentioned before, some of the stormwater actually does make it to the treatment plants where at least it can be properly treated. The difference between stormwater, what's called stormwater, and just natural surface runoff can be shown on this diagram. On the left-hand side is what's called pre-development conditions. There's no buildings here, no pavement. Your surface runoff is just rainfall that flows over a field or over through the woodlands, and there should be no contaminants in there except naturally occurring stuff. Now, once you develop an area, you've got roads, you've got pavements, you've got buildings, and now you're introducing potential contaminants from that. And that's what they call and regulate as stormwater. At the beginning of last week, I introduced the water cycle, which you probably had all known about anyway. Now, with all these activities I've gone over, using water, treating it, discharging it, we're kind of budding our way into the natural water cycle. We're taking some of that water out for use, and after treatment, we're putting it back in the water cycle because it's going to surface water, or it's going to groundwater, or maybe in some cases even an ocean. And of course, some of that water never makes it back because obviously we're consuming a lot of the water. But then again, a lot of it makes it back as wastewater. So maybe we're not affecting so much the quantity of the water, but we certainly can affect the quality. I'm sorry, I said that backwards. We may not be affecting the quantity of the water so much as we're affecting the quality of the water if we're not careful. I'm going to skip that one. I'm going to skip that one. I'm going to skip that one. There we go. Okay, I mentioned before that wastewater treatment plants, their volume that they have to treat goes up a lot when there are heavy rains because there's water being introduced, stormwater is being introduced into the plant, either deliberately in places or not deliberately. And this is a graph from northeastern Spain, and plots rainfall on the left against the amount of treated water at the plant on the right. And they have about a dozen different wastewater plant volumes plotted on here. But the bar graph, if you kind of look behind all these lines, you've got a bar graph. That's the rainfall. That's the rainfall. So when the rainfall goes up, as it did in 2000, you see a spike in the volumes of the wastewater plants. When it goes up, when the rainfall gets higher, in May of 2002, you see a bigger spike in the volume being treated at the wastewater plant. So there's that relationship, and that's pretty general everywhere. That's one time in Tallahassee or South Florida, they get a tropical storm or hurricane. These wastewater plants are stressed to the max, treating water. And even though a lot of it may be stormwater at the time, yet they have everything that leaves their property has to be treated to the same degree. Stormwater cannot be just let go as something we don't have to treat, something they don't have to treat. They do have to treat it. It makes it difficult. Anyone have questions? Might be a good time to see if there's any questions before I move on. We're going to check the chat if you give us a second.
I have a question.
All right. Yeah, go ahead.
What role do water towers play in the water cycle, and how do they work?
Water towers are used for drinking water supply, and they, then in very basic language, I think that's about all I know. They provide a physically high point where some water can be stored, but mostly it's a place they can pump water up to and then let gravity continue moving that water. Think of it as a kind of a pump station or a lift station to help move the water along the way. Those towers that you see don't hold a whole lot of water. I think that's really about all I know about them.
Do they have to have water pumped up to them, or do they siphon water up?
I don't know.
I have a question.
Sure.
Where is Tallahassee's treated water disposed of? Or how is it disposed? Which,
I am getting to that. That'll be in the
Okay.
presentation.
okay.
Yep. One more. Okay.
Actually, I have another question. Does every municipality in Florida have to have a wastewater treatment plant, or every development that's new, do they have to have a plan for treating water? I'm just trying to get a sense of how many wastewater treatment plants there would be in a state like Florida.
Oh, wow. There's actually there's a spreadsheet on DEP's website, and you can actually get an exact number. It's thousands. I think it's
Okay,
it's over 2,000.
okay. I was just trying to get a sense of how many there would be. Not an exact number. Thank you.
Yeah, sure. All right, let's kind of switch gears here and kind of move on from the kind of the more drudgery, the mundane stuff, perhaps, to the kind of putting it all together and looking at our environment. And this slide I just put up here is the environmental movement. The Industrial Revolution, which started over 150 years ago, really changed our environment. And, the world's rising population, the development of industry, increased pollution on our planet. The awareness of this became much greater in the second half of the 20th century. Some of these pictures I just grabbed off the internet show on the left fog or smog in Beijing, China. In the upper right, an oil spill in an ocean or a bay from a tanker. And on the lower right is the burning of the Cuyahoga River in Cleveland in the late 1960s. There was an oil film at the top of the river, and someone, accidentally or not, decided that we're going to set it on fire. That really made the news. These are images that we've all seen, lived through, and they really raised awareness of how we're really messing up our environment. Before environmental movement, how did we deal with our waste? Kind of like these three guys, and over on the left side, see no evil, hear no evil, speak no evil. And part of that would be burying waste. At least we got into the 20th century, we were burying our waste, out of sight, out of mind, which did not show a really good understanding of what might happen. Well, in 1970, we had our first Earth Day. The environmental problems reached a point where millions and millions of people decided we needed an Earth Day. We need to become aware of what our problems are. And we've had Earth Day. It's April 22nd every year, so we just had one. This is on the Washington Mall on Earth Day 2015. Everybody there celebrating protection of our environment, except they need a few more trash cans, obviously. There were, back in the 70s, 60s, 70s, there were a few real high profile situations that increased the understanding of most people about how we really need to protect our environment. One of these situations was in New York State and in Niagara Falls, and the area was called Love Canal. Love Canal. It's a residential area near the Niagara River, upstream from Niagara Falls. A company called Hooker Chemical Company received approval to dump their wastes in what was called Love Canal. The canal was already being used as a city dump, so what's a little more waste? The canal was drained first, so it ceased to be a water body anyway. The company operated the area, operated the property, and dumped a lot of waste. They contaminated soil, surface water, and groundwater for about 10 years, and with about 20,000 tons of waste material. The company thereafter moved off the site. They sold the property to the school district in 1953 and left the premises. 25 years later, by 1978, the extent of the harm was finally realized. Residents had developed health problems. These are people who live nearby. They developed health problems, including cancer, miscarriages, and childbirth defects. The federal government declared the situation a federal health emergency under Jimmy Carter, and federal disaster funds were used to begin the process of cleanup. It was the first time in American history that emergency funds were used for a situation other than a natural disaster. These are some of the scenes from the time at Love Canal. The federal government paid to relocate more than 800 families, and they reimbursed them for their homes. I'll mention shortly what new regulations arose during these times. Even though we're talking about water, the environmental movement also focused on our very poor air quality. Urban smog was another problem that plagued America and the world. There was excessive pollution of the air by industry that had very few, if any, regulations on what could be discharged to the air. All right, now here's another well-known area that's probably still undergoing cleanup, I suspect. It's in Oak Ridge, Tennessee, and it's the site of something you've probably heard of before, the Manhattan Project. The Manhattan Project in World War II was based in Oak Ridge and was dedicated to the development of the atomic bomb. It included working with radioactive material. It was a 44-acre plant, which we see here. Any project this massive is going to generate a lot of waste material that can't be reused. And in this case, much of it was radioactive. And the time, of course, was World War II, before any significant environmental regulations. To work at the project, you had to take lie detector tests. They were administered as part of a security screening at Oak Ridge. Can't tell if this woman passed or not, or if she's still sitting there. I don't know. Couldn't resist that picture. Right, something from the Twilight Zone, yeah. Back then, waste was buried and covered up. If it was solid waste, if it was liquid waste, it was disposed of in some water body. Bury the waste so it's not going to be an eyesore. And this demonstrates a very poor understanding of the risks of doing that. They have to come back to haunt us years later. Military bases, many of them became cleanup sites due to poor environmental practices of the past. Although that's certainly changed now, they are cleaning up many sites under the funding of the Department of Defense, cleaning up the prior contamination in cooperation with state governments and the Environmental Protection Agency. So after Earth Day began, we began to quickly realize we don't have enough regulations, and the ones we do don't have a lot of teeth to them. So regulations followed, environmental regulations. The 1970s saw the beginning of those regulations to address the contamination of air, water, and soil. Many people say nowadays that we're overregulated, but just remember what it was like then. We were vastly underregulated, and public health was in much worse shape. Now this is a book, this is an EPA book called Code of Federal Regulations. It's actually not all contained in that book. They have many books. It's online too. You can get this online. These are EPA regulations. They cover everything they feel they need to regulate, and then some, I'm sure. And the state regulations and the county regulations and the city regulations really trace back to the EPA regulations. Okay, so who regulates the environment? Well, let's start with EPA. That's the obvious place to start. They regulate, when I say the environment, that means air, surface water, groundwater, and soil, I suppose, sure. It was created in 1970, and it preceded most of the state regulatory agencies, headquartered, of course, in our nation's capital. But there are 10 regional offices of the EPA. Florida is part of EPA Region 4, which is headquartered in Atlanta and covers about between 7 and 10, must be more like 7 or 8 southeastern states. A state regulatory program may be run by EPA or by the state, such as, let's say, domestic wastewater program or hazardous waste program. If there's a state program, it must be at least as stringent, as strict as any EPA regulated program. And often they're even more strict than the feds are, because at the state level, there are things that can be addressed more fully than the federal regulations can do. Federal regulations tend to be a little bit on the generic side because obviously they apply to everybody. But if you're talking about groundwater that's used by 90% of the population, like in Florida, your rules might be very specific to groundwater in karst areas. An EPA, they really can't get into those specifics. There are other federal agencies that regulate the environment to some degree. We have the Department of Energy, OSHA, the Nuclear Regulatory Commission, Department of Agriculture, and the Department of the Interior, to name the most notable ones. The Department of Interior includes the United States Geologic Survey, the National Park Service, and they regulate offshore leasing of oil and gas in property in federal waters. Getting down to the state level, and we're only going to look at our own state, we have a Florida Department of Health, or DOH. They are primarily concerned with drinking water and septic systems. Then we come to the Department of Environmental Protection. That was my agency until I retired from them. They regulate Generally, quality. They regulate air quality and water quality, wastewater quality. They also regulate drinking water. Even though I said DOH regulates drinking water, the DEP delegates that to the DOH, and the DOH delegates it to the counties. But generally speaking, DEP regulates water and air quality. They do that through their regulations and permitting and compliance and enforcement. Oh, just want to say here too. So everybody's probably had a question for some regulatory authority before about something concerning your environment, whether it be trash pickup or whether it be drinking water or a discharge of water. You wonder what it is, where does it go? Who are you going to call? Are you going to call EPA, DOH, DEP, or someone else? It gets confusing. I'm going to talk more about that in a bit as we drill on down here to some of the other agencies that regulate our environment. In addition to what I've already given you, we have the Florida Water Management Districts. They are separate from DEP. They regulate the water use and amount of use. So as somebody asked last week, we were asking about bottled water. Who regulates that? The water management districts regulate the use of that water. The Department of Agriculture gets into the act. They regulate certain things. And then, of course, all our counties and our cities and towns have their regulations. The counties regulate at the local level. And that might often include septic tanks, garbage, stormwater. It's typically what they regulate. Cities and towns also regulate some of those things and some other things. There's crossover. Don't know if there's really duplication, but there's a lot of crossover between what Tallahassee regulates and what the county regulates. So again, same question. Hold on, let me check on something. Oh.
Let somebody else in. Somebody's trying to get in.
Okay. Okay, so again, you've got a question about the environment. Who are you going to call? You really want to make an effort to call the correct agency. And you really want to make an effort to call or contact, whether you email them or whether you can call somebody, the correct section or program of the agency. Maybe you'll be really lucky and get a name of somebody. More likely it's a contact to the particular program. If you can do that, you've done really well. How do you get to that level to where you're not just blindly calling an agency? Check their websites. I can speak for DEP's website because I worked there long enough. They have links to every program under the agency. And in those links, there's web pages, and you can find out how to contact each program. Some websites for the agencies, whether they be the city or whether they be the state, maybe even the federal level, they may have a way that you can actually put your question in writing and send it. You may think, well, yeah, that's going to get answered, but really nowadays they generally do make an effort to answer those questions. So the key is do your homework, try and find out how to get in touch with somebody that might actually know about what you want to know about. One of my pet peeves at DEP was always, we had great admins, administrative assistants. Some of them were a little better than others at taking phone calls and getting them to the correct person. I didn't mind if I got a call about water, anything about water, because I usually could direct them to the right program if it wasn't me. But if I get a question on landfills, or I get a question on stormwater, or I get a question on something even less relevant to my job, I may not know who to send them to. All right, we're gonna spend rest of the time I have in talking to go over a few case studies and a few hot topics and local interest topics. Sure, everybody remembers hearing about the Flint, Michigan water crisis, which unfolded in 2014. I only have one slide. So this is a water tower, by the way. Somebody asked about that. Excuse me. So I'll go over it. I'll go over it briefly. What happened and why. Until 2014, the city of Flint got its water from the city of Detroit. That water was treated by the city of Detroit. They sold they had excess water. They sold it to Flint. They just sent it over by transmission line to the city of Flint. Flint didn't have to do any water treatment, presumably, and just sent it out to their customers. All worked really well, but the city of Flint wanted to, they were looking for ways to save money. So they decided they were going to look for another water supply. And they arranged to buy water from a different water authority, which serves some areas near Detroit. But that water authority, that way, they weren't able to use that source of water just yet. So instead of waiting, they went ahead and went back to their old water supply, which was the Flint River. The Flint River used to serve as a drinking water source before they got their water from Detroit. So they still had the infrastructure. So they said, well, let's just ramp this up again and take water off the Flint River. We'll treat it and until we can get our new supply online. Well, they didn't do enough engineering work up front or chemical work up front to be sure that everything was going to be okay. Turned out there was a problem. One thing that came to light is that the city of Flint water piping, the piping that went from the plant to distribution to everybody's household, it was really old. And a lot of that piping had lead in it, lead, which is a primary contaminant. You certainly don't want to have an excess of lead in your drinking water. That's a real health issue. And that lead was subject to corrosion under certain circumstances. Apparently, when they were sending water from the city of Detroit through it, it did not leach lead out of the pipe. But when they sent water from the city of Flint, from the Flint River, when that was the source, it was leaching lead out of the pipe. That lead dissolved in the water. And so people that were drinking the water were getting too much lead. They were ingesting too much lead. And that caused such things as elevated blood levels in children and a whole host of other things. This became, of course, national headlines. Plenty of blame, plenty of heads rolled. Bottled water had to be used for the residents. The city had to switch back to Detroit's water supply as quickly as possible. Michigan government and federal government declared a state of emergency. Charges were brought against numerous public officials. There was replacement of the lead piping, slowly but surely. It's not something you can do overnight, but they're well on their way to getting that done. And a lot of it's been done. Like I said, if there had been an engineering effort up front to evaluate the compatibility of the new water source with the piping system, this could have been avoided. Right, so we had a question earlier about where does Tallahassee's domestic wastewater go to? And that's what I'm going to touch on right now. It's a story I've told before if you've sat in some of my other seminars. Of course, we're looking at Wakulla Springs here. This is a very major spring, a first magnitude spring in the state of Florida. Water flows out of the ground because it's a karst aquifer. This is a map of Tallahassee. The wastewater treatment plant is where I'm moving my cursor. It's near the airport. After the water is treated, it is not discharged anywhere near there. It is sent through a transmission line to what we call a spray field. It's where a farmer or farmers actually rent the land and they grow crops there. And that water has a certain amount of nitrogen and phosphorus, and it's good for the crops. And they spray the land, and it provides a cheap source of irrigation water. And that water soaks down into the ground. So that's how the city gets rid of its water. They use an irrigation spray field, and they've done that for many years. Before that, they actually discharged it to, I think it was Munson Slough, which is a river or stream that runs like so near the treatment plant. That's a picture of the city's wastewater plant. They always name wastewater plants and drinking water plants after local people. So if you have done well in your community, perhaps someday you will have a wastewater plant named after you. This is a picture of the spray field. Each one of these circles represents an irrigation spray field setup, and it shows about 11 of these here. This is probably an old diagram. I thought I had a picture of that, but these are very large irrigation systems. Now, when that water is sprayed, it's what the water that's taken up by the crops. Some of that used by the crops, and then some of it evaporates. The rest of it infiltrates into the ground. It goes through a thin layer of sand and into the limestone. On the left, you can see how deep the sand and the limestone are. Between a depth of 20 feet and 80 feet, you're in limestone, and that's the Floridan aquifer. So all the water that is coming from the city and being irrigated, what isn't taken up by the crops or evaporating, is going into the Floridan aquifer. And the spray field site is located about 7 miles north of Wakulla Springs and other springs. Groundwater flows. We know that it flows generally to the south. If you look at these arrows, one here and one here, they're flowing to the south. This is the spray field. What they noticed over the years is that the water quality of Wakulla Springs deteriorated, and they learned that there was too much nitrogen, particularly, and some phosphorus that was making it to Wakulla Springs, and it was causing algae to bloom in the springs and the growth of hydrilla, which was really deteriorating the water quality in the spring. So the city upgraded their treatment, and they finished that in 2015. They added a process to reduce the amount of nutrients in their wastewater. That means reduce the nitrogen and the phosphorus. So the water going to the spray field now has less nitrogen and phosphorus in it. And over the time period that began, we've noticed an improvement in the water quality in the springs. I think they're still not running the glass bottom boats, but hopefully they get to the point someday where they can run the glass bottom boats again. Cascades Park, we know about that. One of Tallahassee's finest parks, but it wasn't always that way. Took a long time to reach that status. This used to be an EPA Superfund site. Super sometimes means great thing. Sometimes it's a bad thing. Superfund referred to sites that had hazardous waste that needed to be cleaned up. If your site made the Superfund list, that was not a good thing. However, you would get funds to clean it up, so maybe it was a good thing. Before Cascades Park was there, the city operated between the 1890 and the late 1950s. And there was a landfill here also. The plants made gas from coal, and the waste went to the landfill and to nearby areas. Here's an old picture of part of the operations there. The city began investigations in 1985 about the impact of these operations, which had not been going on for 30 years. The city worked with DEP and EPA to study the impact to soil and to groundwater. And that's when they got it listed as an EPA Superfund site. So there were funds to clean it up with. Many tons of contaminated soils had to be dredged and removed until EPA and the state were satisfied that the cleanup was complete. In fact, EPA awarded Tallahassee the Excellence in Site Reuse Award for exceeding expectations in their cleanup effort. So this, as you know, the city redeveloped the land into Cascades Park over the last 10 years. In 2019, EPA declared no further action was needed. Success. One of the things you may or may not remember, I call it the Chromium 6 story in Tallahassee. In 2011, it was reported that the city of Tallahassee's public drinking water supply had high levels of chromium 6, something called chromium 6. As the story goes, supposedly individuals took samples of the city's tap water and had chemical analyses done on them that showed high concentrations of this chemical. A national environmental group publicized their summary of the results. Chromium is an element. It's Cr, it's where I'm circling on the periodic table. Technically, it's a metal. Number 20, atomic number 24. There are different varieties of chromium though, and generally chromium is not a health hazard as long as it doesn't exceed the concentration in water as determined by EPA and the state to be safe. Chromium 6 is one of the potential forms of chromium, however, that has been highlighted as being potentially toxic. Tallahassee tests its water annually, at least for everything regulated by EPA, including total chromium. If the water sample were to contain over 100 parts per billion of total chromium, it would have to be tested again. If it still had high chromium, consumers would be notified, and the water utility, meaning Tallahassee, would need to investigate. So what did the city do when this news came out? They requested a copy of the laboratory results so they could see they could look at what was being publicized. This is a typical laboratory report with all technical information. I'll go over it, see what it looks like in a bit. But the gist of it, what happened was that the environmental group would not provide the city their results. They did not release them to anybody else either. So the city had to take many samples of its drinking water at different locations, and they had them all tested for chromium, total chromium, and chromium 6 separately. A Florida State geochemistry professor who may have been part of that study also did testing and sampling. No sample results ever came back with high concentrations of chromium in any form. This is just a typical drinking water drinking water report for a test. It lists the different contaminants such as nitrate, chromium's there. It's kind of hard to read, but it lists the safe level, which is the MCL, maximum recommended level, and then the results, which is in the 5th column. It lists the results. In this case, chromium was 1/10 of the regulatory limit. So Tallahassee unfortunately had to spend a lot of time and money chasing something that never was really proven. So kind of comes back to that thing we're always hearing. What does the data say? Look at the data. If nobody gives you data to look at, you're kind of grasping for straws. All right, finally, bottled water. Good or bad? Well, it is good or bad, depending on your viewpoint. But we sure do drink a lot of it. In 2018, 13.85 billion gallons of bottled water were sold in the US. And this was 4th per capita in the world. Mexico, Thailand, and Italy were the top 3 countries, and US was 4th. And you can see what this number equates to. 42.3 gallons per person in the US per year, or 5,414 ounces per person, 677 servings of 8-ounce cups, or 1.85 cups per day per person. Now, how much does this cost if you're relying on bottled water? Now, unfortunately, some people do rely on bottled water because they live in areas where they can't get a reliable, safe source of drinking water supply. For those of us who have a choice, you may want to think about some of these numbers. Assuming you buy a 12-pack of bottled water for $3, that's 25 cents per liter, or $1 per gallon. If you get your water right out of the tap in Tallahassee, the city charges you at the most 34 cents per 100 gallons, not $1 per gallon. If you wanted 100 gallons, let's see. All right, anyway, that's very expensive. Might cost the equivalent of 50 Big Macs to get 100 gallons of water this way. Anyway, you can see relying on bottled water, if you don't have to, is actually quite expensive when city water is just so cheap. Now, tap water or city water, or if it's provided by the county, in any American town is tested as required by their state regulators, their state regulations, and the EPA. Tallahassee tests their water annually for the whole suite of 100 or so parameters, but there's some parameters that they do test much more frequently. Bottled water, on the other hand, is regulated not by the EPA, not by the DEP, it's regulated by the Federal Food and Drug Administration, and it requires much less stringent testing requirements. And I believe most of their testing is really more for quality control, internal quality control, than anything else. Going back to an earlier slide, I mentioned the Florida water management districts. They regulate the withdrawal of surface water or groundwater for use. And that includes bottled water companies. Anybody that wants a water use permit or consumptive use permit would need to get that from the water management district. They last about 20 years. They may be renewed. They specify the volume that can be taken from the water supply source. The person getting the permit must demonstrate there's no significant impact on other water resources. So I know some of you, and me included, Maureen too, don't care for the fact that companies are getting permits for large-scale bottled water operations. But that operation must have made this demonstration to the water management district that there would be no significant impact on other water sources. So you ask, how can they get that permit? That last bullet, they made some demonstration. If you make that demonstration, by golly, you're probably going to get your permit. It's funny, I've dealt with the water management districts plenty of times, and I still do. And they always would say, you know, we've got to recharge more water into the aquifers. We can't be wasting water. I'm thinking, well, then why do you give water use permits to companies like that, that bottled water? Don't seem real compatible goals. There are 5 water management districts in the state. They have geographic areas. Those are their names. Tallahassee is within the Northwest Florida Water Management District. They are headquartered in Midway, Florida, which is near Quincy or Ravenna. So they're the ones to complain to if you don't like bottled water permitting. Finally, last slide. Plastic in our waters is a pollution problem for sure. Large pieces speak for themselves, but now we've discovered there are microplastics in water, not only in water that have obvious plastic in them, but also they have found microplastics in groundwater and even drinking water. A 2019 study by the World Health Organization concluded that there's not enough evidence to conclude that they pose a risk to human health yet. But it does caution that more research is needed to draw firm conclusions, and there is plenty more research going on. Somebody asked last week about Talquin water. I don't know if that lady still is here today. I think your question was, where does Talquin Utilities get their water supply? I found out very little online from them, but all I can tell you is they get it from surface and groundwater sources. So they must have their own water supply wells as well as surface water sources. Perhaps Lake Talquin is supplying part of that water, but I found out very little online. So I am done, and we're going to open this up for questions. We want to just ask who's got questions. How do you want to do this? Okay. Just go ahead and ask your question or questions, please.
You can unmute yourself if you want to ask a question.
I left you something in the chat. I wanted to know where the solids from wastewater treatment go in Tallahassee.
Well, okay. Specifically Tallahassee, I don't know where their solids go from the wastewater treatment plants, but some of them will go. Some of them could be in a landfill. That's kind of become a big issue in the state. They're called biosolids. They don't like the name sludge, so I call them biosolids. Same thing. They can go wherever a place is large enough and permitted to accept them. They're usually used for spreading on land somewhere. They've got a lot of nutrients in them. So they have some beneficial use. I don't know specifically where Tallahassee's goes.
Did you read it?
Where am I up to?
What control?
Okay, what control do the water management districts have on bottled water?
Yeah, you answered my question when you were presenting. Yeah,
I tried to highlight what I really think is the main thing, that they can run a model to demonstrate that there's not going to negatively impact other groundwater users. And it's kind of hard.
Excuse me. I know those people are elected from time to time. Maybe would you address the possibility or a good idea to ask the people running for election whether they voted to allow Nestle's permit.
Yeah. The Water Management District has a governing board. Each one has a governing board, so they would be the ones to direct that too. I don't know if they're elected or they're appointed.
I think they're.
They're elected. They're elected.
All right.
We just elected a bunch of them. I was wondering what happened to the dirt, the contaminated earth that they dug out of Cascades Park.
I don't know that. I know people who do know that, but I don't know that. If it was hazardous, it certainly wouldn't be going to the landfill.
I hope not, but where does it go?
If you can find out,
I'll-
email the group.
Probably out of state.
Ooh,
Yeah, look
I'll-
that up and
I'll ask some contacts I still have at DEP. Did not burn all my bridges. I have contacts at DEP and I'll ask them that question.
thank you.
Know about using water during hurricanes. It seems like I've never had electricity being out or anything have an impact on my tap water supply, but I want to know if there's any concern for it because, you know, they always want you to buy up bottled water for hurricanes.
Well, there is a possibility that the city's electricity could be really impacted. And if you lose water, if you're a city customer and you lost water in a storm, it would be because they can't transmit that water to your house. They've got electrical problems. The pumps, the lift stations aren't working. But yeah, all this time we've lived here, we've never lost water.
It's more likely if you're on a well.
If you're on your own, if you have your own well though, it's much more important because if you just lose power to your house, you won't be able to pump your well. Anyone else? Question?
If there's no more questions, thank you all for attending today. I've been here the whole time working on my work computer, which is next to this computer. So thanks so much, Joe, for doing this. I will email everybody the recording, and I will also email you the answer to that question if you can find the answer. I have everybody's email. So I can
Thank you for the presentation. It was very good.
Thank you.
Thank
You'll-
you.
Appreciate it.
Everyone have a good afternoon. Check out our upcoming classes on TallahasseeSeniorFoundation.org.
Okay.
Bye.
Thank you.
Bye.
Welcome.